good first start. I've muted myself. So technical difficulties there, but I'll try with the audio. That sounds, hopefully should sound better. Do shout if you can't hear me. Um, should be good now. Let's give it a second. Let's see. Okay, cool. Looks like audio levels are good. Let me see. Do we have the chat there? Awesome. Let me just add that in. Cool. So as I was saying, we're going to try and dust off the cobwebs with some Kaggle competing today. We're going to try the Playground series. So we're going to be looking at the tabular data sets. Very easy, very simple to start with, but it's all about kind of just learning and getting back into the swing of competing on Kaggle. So let's give this a go. Let's bring up the competition. Here we go. So we haven't even joined the competition yet, so this is all blind. Um, all blind. Excited for this. Thank you, Catherine. Yes, I'm excited to start. It's going to be really good, I think, for me and you guys. We're going to try and learn as we go along. I'm not going to be an expert by any means, but it'd be good to kind of learn as we go and get everybody involved. So if you see me doing something silly or you've got any suggestions, please throw them out in the chat. But hopefully we can get through to a competition submission and do pretty well. So let's start by joining the competition. So if you haven't been on Kaggle before, there's a number of different competitions, and before you can even see the data, we've got to join the actual competition and agree to the rules. So let's do that. One account per participant. That's okay. That's just me. Let's understand and accept. I understand and agree. So let's get a flavor of the data. So what's the aim here? We are, let's check the overview for the evaluation. So we're looking for the mean absolute error as an evaluation statistic. And what we're trying to do is predict the yield of wild blueberry growth. So let's have a look at the data itself real quick before we open up a notebook. So this is our training data set. So it looks like we've got a number of different variables here. So what are these actually in relation to? Let's open up the original data set. So all of these tabular data sets are based on previous code competitions, I believe, and then they kind of tidy up the data. Or they have different model data sets. So they just tidy up that data. So let's data set used for predictive modeling was generated using the wild blueberry pollination simulation model, an open source model. So this is looking at blueberry plants. I see. So we're looking at blueberry plants and how much yield we get from the blueberry plants. And we've got a number of different features. So let's double check these are actually the same in the original data set as to the competition data set. So we've got clone size honeybee bumbles. Let's just double clone size honeybee bumbles. Okay, cool. So I don't think there's much description of the features in this, but there is more of a description in the original data set. So let's skip this for now. Let's get a notebook open. So easy way to do this, code, new notebook. All right, we'll pop open a new notebook here. Again, so if you've never used Kaggle before, these notebooks are kind of online Jupyter notebooks running Python or R. I think you can specify here the language you want. You can switch between the two. I believe if you've got, oh, let's keep that in there. Let's just remove that for now. Because it's markdown, you might be able to specify like that. Does that work? Let's boot this up. Let's get this session going. Let's give ourselves a good title for this notebook so we remember what we're doing. Wild blueberries. Or wild blueberry. No, you can't run that R function. Wild blueberries. Predicting the yield. Okay, cool. Let's see if we can start looking at the data. So first we're going to import pandas. And then luckily for us, Kaggle puts our data in this notebook accessible path. So let's read in the data. Let's call it train. And that is equal to, let's read the CSV file, and we have this path here. So in Kaggle notebooks, they're all on the input here. And let's give that a go. Oh, we didn't import pandas correctly. So, actually, while we're at it, let's just import test. Copy that. Which background audio have I got? I'm just going to bump up the desktop audio. Does that come in? Give it background music, see if that works. Cool. Shout if that's too loud. It's a bit loud in my ears, actually. Let's turn this down a little bit. Okay, awesome. Cool, so we've read in the data sets. Let's have a look at what they say. So, oh, hello. We can see we can spy on the different types of data. So, I think in these tabular data sets, I think you rarely ever have categorical data. Is that the case? Are they always... So the aim with these kind of tabular playground series is that they're very easy and approachable. Here we go, lightweight challenges, synthetically generated real-world data. So I think they rarely ever have categorical data. I think they're mostly all numerical features, so there's not too much you have to do in terms of encoding or anything like that. But let's go through and see what we can see in the data. So we've got all of these variables. So clone size, the average blueberry clone size in the field. Honeybee density, bumblebee density. So we've got 4 different bees in the field as a feature. Max of upper temperature range, highest record of the upper band daily air temperature, lowest daily air temperature, average daily air temperature, highest of the lower band, lowest record of the lower band, average of the lower band. So it looks like we've got band of air temperature, and then we've got the average, the highest record of the upper and lower. So I'd imagine that is, well, let's have a look at the data. Yeah, it looks like we're going to have quite a bit different temperature data. Is this, let's see, is this a specific recording time, or is this simulation model 30 years? I wonder if this tells us it's a time series, or is it just a simple regression? Let's see. let's start getting some information in. So Kaggle notebooks do have some good markdown formats. I'm going to quickly, let's see if I can get some good markdown formatting from a previous notebook. Let's have a look. Not that we want to worry too much about making it fancy, but let's at least start with a good. Right. This is a good markdown. So yeah, let's get our feature descriptions into the notebook so we can actually see as we're going. So let's copy this from another notebook. So I believe this formatting comes from. Let's see if I can find him. Let's give him a good reference. Is this it here? So there's a guy. There's quite a few notebooks that I quite like his formatting. Oh, he's usually at the top. Why can I never find him now? That's not him. The best score? No. Never there when you need it. Yeah, I think it's in here. Here we go, here we go. So, Leonid Kulik. I'm gonna butcher that name, but there you go. This Kaggle, he makes some very nice, nice looking notebook format. So we're gonna borrow some of his markdown formatting, and then make sure we do reference him when we do. So let's do that now. We scientists stand on the shoulders of giants. So let's make sure we give him the credit he is due. I hope he hopefully he didn't steal it from somebody else, but let's see. So let's copy and edit his. Let's copy and edit his notebook. We'll get a nice overview and a title. Cool. So if we borrow those for a second, let's get a title going. Let's not steal it too much, but we will reference. So let's change the title up. So wild blueberry yield prediction. Let's drop that. We're gonna. What's our goal? We're gonna predict the yield of blueberry plants. give you much description here, do they? We're gonna say plants. Let's just say blueberry plants. Let's drop these emojis real quick. And like I said, for correct accreditation, let's give Leonard his his let's say notebook starting inspired by. Cool. Okay, let's start filling this in. So let's drop some of this. The goal is to predict the yield of blueberry plants based on features, based on some data. Based on a set of features. Importance. There's not a huge amount of importance to this. Let's drop that. So we know what we're doing. Right, okay, we're going to import the library that we need, so we're going to add to this in a bit as we get some more data sets in. Let's drop this. So we have the following features for each. Growth cycle. Are these growth cycles? How are they? Clone size. So this, let's just double check. So is this plant data? Blueberries are flowering plants. Blue or purple berries? The data set. Plant spatial arrangement. So this is the only downside of these tabular data sets. Sometimes you don't get a lot of background information, but let's give it a go. I guess let's just call it for each plant growth cycle. Are they growth cycles? Is that what we'd call it? So what each one of these is. Bloom season. This is the yield of the. This might be. Or is this? Okay. I think this is actually. I see. So this is a data set of. I think it's each year of growth and yield return. So I guess each season, each growing season. Yeah, that would make sense with the clone size, honeybee density, and then the actual temperature variations and average rainy days during the bloom season. So, yeah, each plant growth cycle, or for each crop season. Let's call it crop season. Let's see. Our task is to devise machine learning to predict yield of blueberries based on the features provided. And let's take those features so we've got them to hand in our notebook. And I believe if I just Wait. And what have I missed? What have I missed in the data? Markdown. Let's have a look. Let's have a look. I've missed some, I guess, closing brackets in the markdown. Oh no, I see. No. You've had a character. Oh, we're not allowed. Not allowed degrees Celsius. Let's change that. Does that work? New. I get invalid syntax on that. Oh, we're not in markdown. That would make a whole lot of sense. I did wonder why 4 and yield were highlighting. You gotta make sure it's a markdown text box. There we go. Let's get rid of that. And then let's bullet point these. It's gotta be a quicker way of doing this, but I just go by gamer typing. And let's drop the bullet point there. Oh no, is that a spam in the chat? Cool, love it, Gabriel, thanks. Let's add you to the block list. Okay, cool, so we've got our data description for each feature. So let's look at these features again. So yeah, we can see they are all tabulated numbers. And then we've got a target variable here, yield. So what you'll see is if we look at our test dataset, we have all the features and no yield. So that's what we want to predict. So this is the set that we need to predict on and submit to the competition. This is the data we want to train our model on. So let's drop that a little bit. Let's start doing some EDA, exploratory data analysis. So let's, do we want to use that? Let's, so there is a nice package called data prep that I do like. Do I want to use it? Yeah, why not? It's very easy. It's very easy. So let's install a package. I do love this package. It's so let's run pip install. So we'll use the exclamation mark on pip in the Kaggle notebook to install it. Let's scroll the ball. It's quite a big package, but it's quite useful. So let's just get that ready. And I believe the functionality is pretty easy. Pretty sure it's just as easy as doing create underscore report, but let's wait and see. Cool, so we've installed that package and imported it, so I'm fairly sure the syntax is just this. just this. Nope. Okay, let's review. Let's review the documentation. So data prep is like an automated EDA, so exploratory data analysis package and tool. So that will do a lot of the heavy lifting for us when we want to look at the data. So here we go. So we actually need to import it as dataprep.eda. Yeah, and then we want to bring in our create report. We're getting a bit of a package error there, but let's see if this works. And then create report. Yeah, it should just be the same as this. So this should give us a nice output of EDA. So what it just shows is the kind of distribution of the data. Is there anything that looks particularly interesting? Yeah, how's the data distributed? Is it skewed? Is there anything that we might need to do? So let's have a look. So sort by feature order. ID is slightly inconsequential, so that's just how Kaggle double checks against the test set when it's doing the submission, so this isn't a relevant feature for us. Clone size, so it looks like we've got most of these look like they're skewed very much to the left. They're logarithmic. Is there any missing data? No, which is good. Again, I think most of these playground data sets, they're not ever missing data. They're clean and easy to use, so we don't have to worry about imputing data or adding data or dealing with missing data. No duplicate rows. And let's have a look at this. So the bees, the bumbles. So these are the different types of bees. It looks like. So let's remind ourselves on actually what the data type is here. The honeybee density in meters squared per minute. So it looks like the majority of the observations are 0.5, 0.25. And yeah, it looks like we've got some slightly more normal distributions here. They're a bit skewed. And then the temperatures, they're pretty uniform. So there's a nice interesting normally distributed fruit set. So what's fruit set again? Let's have a look at that. Where is fruit set? So these look like slightly different variables. Do we have extra variables in here? Fruit set, fruit mass, seeds. Oh, okay. So we've got extra variables in here compared to the original data set. Okay, interesting. So we've got some more interesting variables here. Let's add these in. I'm not entirely sure what they actually reference at the moment, but let's at least add them to our data set. Fruit set. Fruit mass. Seeds. And I guess we should add yield, our target variable. Oh, they're spaced. Okay, cool. So yeah, you can get a good sense of the distribution of each of the features in here. If they need transformation, let's not worry too much about that for the moment. You'll see these are new features, quite normally distributed. I wonder if they're added synthetically. And then yield, again, normally distributed, similar to these here. So I wonder if these are going to be more intrinsic to the yield. So you can plot on this data prep the interactions between different variables and target variables. So most interestingly is going to be putting yield on the y-axis because that's our variable of interest. So let's go through these. Let's see if any of these seem to make sense. So these look like they are discrete against yield. So it looks like we've got quite a lot of groups, right? Clone size 25. So it doesn't look like there's a continuous data stream here, but let's keep going through. Yeah, again with the bumbles. These do look like they're discrete sets, so yeah, it looks like the yield. If we did this the other way around, looked at the honeybees, yeah, there's not a huge amount of correlation. Let's swap that around again. So I'm guessing fruit set, fruit mass, seeds. These look like they're going to be more interesting. These look like they need some adjustment. These look more like categorical, not categorical, the discrete interactions with yield. And then of course, let's just double check. Yield and yield is 1-to-1. So I think these are going to be our more interesting target variables, but we can go through and play. Correlations. Yeah, we can see here actually looking at this. So correlations are pretty low for these variables, but very high for these variables. This fruit set, fruit mass, and seeds. I wonder how important the rest of the variables are going to be in this exercise. So we've explored those a little bit. Let's do a simple, quick baseline model. Just using, let's just throw all the variables in. Let's give it all a go. So what we probably want to do is use every data scientist's favorite baseline. Let's bring in XGBoost. Oh. So I'm going to bring in the XGBoost, so it's in gradient boosted regression model. And what we can do is very quickly mock up a baseline model. So let's call this baseline model. Let's actually just start segregating these out. Let's get our title. So this is EDA. Some exploration of the variables. Alright, let's call this. So this is going to be, let's call this baseline modeling. And the goal here is to set a benchmark for our model. So we're going to be real simple. Let's just get everything. Let's just throw everything in. So what we want to do is really prep the data for modeling. So we want to pull out the names of each of our features. So a quick way of doing this, I always find, is pull out the columns. And we want everything, right? Ooh. We want everything barring yield. So let's create a new, let's call it features. Make this a list. and then target is equal to yield. And then what we want to also do is we want to so before we make a prediction, so we've only got a training data set to be able to actually see how well we're doing with our modeling performance. So we actually want to split this data into training and testing split. So we've got our test and train data sets. We want to actually take our train data set and further split this into another training and test, so that we can test how well our model is doing on our known data set. So how does this work? Let's create a copy of train, and we'll call it, what's the best way to name this? Let's call it train underscore df is equal to train features. No, it isn't. Yes, it is. So we'll call it train underscore x is equal to train features. So what we're doing here is we're saying we want this data frame, but we only want these columns here. And then we're going to do train underscore y, lowercase y, is equal to train dot target. So what we're doing is taking all of the rows of just the features, just the targets. We're calling out our x and y variable. Then what we want to do is import another package with a nice useful utility. So it's from scikit-learn. Is it from, I think it's from dot model selection import train test split. Cool. That works. So what we want to do here, let's just close this up a little bit. So what we're going to do is split this into a training and testing set of data with our known variables. And we want to do that with probably about 80% train and test against a further 20% holdout set. And what that gives us is a good amount of data to at least train the model on, and then understand where we are in terms of model performance. So let's prep that now. So this is going to be train test underscore split. We're going to give it our train underscore x, train underscore y. I'm going to say test size is equal to 0.2. So that's going to give us, it's going to take all of this data and randomly select 80% for training, and then give us 20% for testing. So this is going to create 4 variables that we need to name. So we're going to call it x and hit insert. We're going to call it x underscore train, y underscore train. Then we're going to call, so that's our 80% training test set. Then we're going to call it x underscore test, y underscore test is equal to train test split. And that's going to give us, so this is going to be all of our features. So both these are going to be feature sets. These are going to be target variable sets, and they're going to be subsets. So let's just double check that's all right. Let's just check these look correct. Okay, so we should have everything bar ID and yield, which X looks correct. Let's just double check Y train. That doesn't look correct. Why are you not correct? Oh, have I done those in the wrong order? If I do that, is that going to be just Y's? Yeah, okay. So you have to actually do these. You have to do the feature sets first. Yeah, so these are our... Yeah, these are our training, and these are our... Let's not call them tests. Let's call them validations. Because it gets very confusing otherwise with all the tests and trains and tests. So let's call them X-train, and then validations. Let's give that a go. This is why we check. So yeah, the train should be all the features, and then let's just check Y train. Yeah, they should all be yields. Let's do the same with validation. Cool. Real quick. Alright, cool. So what we're going to do is we're going to train a model on the X-train data with the Y-train variable, so the algorithm knows how well it's doing. And then we're going to use the X validation as a predicting dataset. So we're going to test our model predicting on the X validation features. And then what we're going to then do is compare how well we've done with those predictions against the Y validation set. So this is our holdout data set. And that's going to tell us how well we think, or how well the model is performing once we do that. So let's set up our model. So what do we want for XGBoost? So we need to define some parameters. What's the quickest way? The quickest. Pretty sure. Let me get. A simple. Let me get a simple XGBoost model. So let's define. So what we can do. Actually, let's define our model space elsewhere. So we want to define some parameters for the XGBoost model, which are all going to be here. Do we want to do training? Yeah, let's do some tuning at the same time. So let's put in some functions from. Is this gonna? Cool. So what we're going to do is we're going to tune the model as we go. So what we're doing is we're bringing in a number of different parameter spaces. So these are all the kind of XGBoost parameters, and then we're giving them a different range, different distribution to test different parameters over. Then we're going to define a function that tests basically each of the parameters in the different space and see what it comes out with. And we're going to give it a evaluation data set that's going to tell you how well it's doing. So it's going to know as it's going along how well this is going to work. So let's get this all set. So we're going to change the metric to MAE, which I believe is the evaluation metric. MAE, yep, mean absolute error. Let's leave all this kind of as it is. Let's just make sure any X underscore tests are correct. We've got everything set correctly. We're going to run a number of trials. So yeah, let's just run these. Let's see if anything goes wrong. Thought it might. Let's have a look. What have we done wrong here? Debug. Early stopping rounds is deprecated. Oh, yeah, we didn't set GPU, did we? So let's set our accelerator up. I don't actually know which is the best one on here. I've never bothered checking, but let's set this up. I believe this restarts the notebook, so we might have to just start everything again. Let's run all from here. Let's just get that going again, reset everything. So yeah, let's just, while that's running, we'll talk it through again. So what have we done? We've taken our features. So these are all the different features that we've got in our data set. We split them up into X and Y. So Y is the target variable set, and then we further split this into an 80-20 training test split. And then and then split that so that we've then also got a holdout data set. So that we can then test the model with what we're seeing before we actually do a submission. Right, and then we've just enabled the GPU. So I think this hyperparameter. So yeah, and then we're let's delete that. So then what we're also doing here is, rather than trying to go through manually and work out what's the best parameters, we can let the computer do that with a nice package called hyperopt, which will go through and test the different hyperparameters for us and look across that space for the optimal hyperparameters. So where did we get up to? Did it run all these? No. Why are we running slow? Ugh, what's happened here? Why are you horrible? Oh, is this Dask? Let's just drop data prep. Does that run? Okay, cool. We can fix that if we're going to publish this, but let's just drop data prep for the training. Let's just close this. Let's just mute that. So yeah, let's just check I'm streaming okay. Are we connected to both? We're still live. Still live, okay. Yeah, let's get going on this. Let's not dilly-dally. So let's get a baseline. So yeah, we're gonna do the split. We didn't read in the data because we got stuck. So we've read in the data. Let's skip the EDA for now. We've already had a look at that. Let's create the test train split, and let's import the space for hyperopt. That's good. So this is going through and saying we're creating a model, XGBoost regressor model. We're looking over the space, so our different parameters. We're going to evaluate against our holdout training set and a holdout validation set. We're going to fit the model.fit. So what this does is just simply takes our training data, creates a model run based on the MAE evaluation. So it's going to minimize the MAE evaluation metric as it's training that model. It's going to take 100 early stopping rounds. We're going to set both to false because we don't want to read this multiple times. We're going to predict. So we're going to make some predictions with our validation. We're going to then, we want to get the MAE rather than the RMSE. So let's double check how we get MAE from sklearn. So these are just metrics.mean absolute error. So we don't want the RMSE, so absolute. It wouldn't be too onerous, but it would also give us the wrong metric to double check how we're doing on the leaderboard. So that's, where did we import that? So let's re-import the metric. So we've got the correct metric. And then yeah, for each of those runs, it's going to return the loss of MAE. And then what hyperopt is going to do is going to keep going through those and the different hyperopt parameters to optimize our hyperopt parameters for our space. This should now work. If the percentage goes up, it's good. No, okay. Error number 2. What are we catching here? Why test is not defined? See, I knew that would happen. Because we changed it from test to val. Let's give this another go. Errors, 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 debug. Oh, mean absolute error got an unknown keyword. That's a holdover from RMSE. So this is what happens when you reuse your data. Okay, it looks like we are running with lots of eval metrics, so we probably should have got rid of the warnings, but let's enable scrolling. So what we can do for future, I believe we can filter warnings to ignore. Let's quickly do that actually. Let's wait for this to finish because I think you have to rerun the whole. So what this currently is doing is running through all the hyperparameters and looking at the best loss figure. So best loss being the MAE. So we're getting a loss of 352, which doesn't sound particularly amazing. Let's have a look at the leaderboard. Okay, so the mean absolute error, we're in the range of 336. So where's 352? We just ran this model and predicted now. Where would that's going to put us very, very low. Remember, this is our baseline, so fingers crossed. We hopefully wouldn't be running that as is. Uh, 352. You also got to remember the public and private leaderboard is not exactly the same. So once we run a submission, we'll see where we end up. But yeah, we'd be somewhere down here in the 400s out of 783. It's not amazing, but not the worst. So where did I actually end up? 351. Okay, cool. So this is giving us our best hyperparameters to use. So that's really just gone through and just tested everything in one go. So we actually want to take all of those. So how do we get that? Trials. So we want to access the best model parameters. So I think we take from the trials. Let's just double check that. Trials.results gives us all of the results of our trials up here, so I think we did 100, so this should be, let's double check, 100, so yeah, it's the data from all of the trials, and we want to return the smallest result keyword loss, so we want to return the smallest one of these. And we'll loop through for result in trial.results. When will that run? Oops, we haven't imported NumPy. Trials. So this is our smallest loss. What we actually want to pull out is all of this here. We want to pull out the best model. So keyword model. Oh, this is fancy. So it gives us our best XGBoost regressor model. So let's just call this best. So out of all of those trials, this is our best trained model. So let's print that out again. So this has given us all of the different hyperparameter variables here for the range that we've given it. Has gone through all of that and given us the best version. So this is all, again, all based on our not clean, not prep data. So let's just treat this as a baseline. So now we want to actually predict with this model. So we want to say XGBoost predictions is equal to our best model dot predict, and then we're going to call our xval. Are we going to do our xval? Yeah, we're going to do our xval. So we're going to predict on our unknown test data set. Let's have a look at what that looks like. So we're definitely getting out some results. That looks good. And then we're going to get our MAE for those. So that's going to be mean absolute error is equal to, no, that's the function. So the y true and y predict. So our y true is our y underscore val. And then our predictions, XGBoost predictions. So yeah, this is our best model, which I think would have been what we saw up here in our best loss. So that makes sense. So we're getting a 351. So I think, as we said, 351 is not going to put us at the top of the leaderboard, but 351 might clear us in the top 300 as a baseline. So let's just get a baseline done today. So we've got our validation holdout test set. We think we're going to be performing about 351. So let's actually do our let's do our actual predictions. Actually, first of all, let's have a look at our features. Can we get our feature importances? So we want to pull out. Can we pull out our so we can. So what we can do is let's steal a bit of this data here. We can have a look at actually which features were the most important when we were plotting that model. So fruit set, seeds, and everything else wasn't nearly half as consequential. So as I kind of thought, yeah, the highly correlated fruit set and seeds seem to be more important than the rest. That's not to say these aren't useful data sets and features. We just maybe haven't transformed them into anything useful yet, so maybe that's something we need to explore later. But again, this is just our baseline model using everything and just throwing it into the XGBoost. So let's do some predictions. So all we need to do is say our predictions are our best model dot predict, and we're going to be predicting our test. What do we call it? So this is our Kaggle. Let's close that. Test set. Did we change? No. So this is our Kaggle test set. So let's just remind ourselves what that looks like. So yeah, we're going to be testing using all of these features. So we're going to feed all of these features into the model because that's what we trained it on, and we're going to then predict. What we need to do is call this test in a df and then dot drop ID. Let's just double check that. Oops, we didn't. So we're going to create test in a df equals drop ID. Let's just double check that works before we assign it. How do we drop in this? Pretty sure it's just dot drop, right? What am I doing wrong here? I'm fairly sure it's just dot drop. Oh, is it not? Sorry, it's not subscriptable, is it? There we go. ID not found in access. Is it not? It's right there. Why are you not dropping? What am I doing wrong here? Should just be dot drop, right? Oh, I have to call columns. Right, I gotta call columns. Yeah, I think it was looking in the index. Okay, so this is our test set using all of our features. So what we could have done alternatively is actually do test under df equal to test features, which actually probably would have been neater because that's how we encoded them all. So what we so if we ever do change our features, we can just call features again, and that gives us the right variables. So let's now run this. So let's again check before we assign. So we are getting predictions. They look semi-reasonable. So let's call this predictions. And then what we need to do is look at the sample submission format. So it's not as simple as just uploading a load of numbers. We will actually want to check. It has to be submitted in the right format. So let's just read that and make sure we're doing the right thing. So what we need is IDs and yields. So it actually has to be named yields, and we need to get the IDs. So so we know the sample submission should be the same as 1,194 rows. So that should be the same as the test df.shape 1,194. So we can just sample submission can we do that? Yield is equal to predictions. And then let's have a look at sample submission. So we've actually overwritten all of the yields in there, and they should all line up with each of the IDs. So now that's nicely formatted. We can say to CSV. We'll call this submission.csv. And then we should have in here, let's give it a second. There we go. We've got our submission file. And then what I could do is click submit on the actual. So Kaggle wants to find submission.csv in the output file, and it will read that for submission to the competition if I hit submit. The one issue with that is all of this has to run by itself independently without breaking. So let's just double check all of this is actually going to work. So let's just run. Warnings is not specified, so that's not going to run. So how do I... Oh, yeah, because I've not imported warnings. That should run. Let's comment this out for now. So we're just going to delete everything that shouldn't run, or it's not going to work if I submit. So, cool. So, let's get our baseline in for now, and then we'll stop there, I think, for the afternoon, evening, and then we'll come back to this for some more feature engineering. So, if we hit submit, what this should do is run the whole notebook, and then look for the output submission file, and then submit that to competition. So let's call this XGB baseline. So we've just thrown all of the features in, and then created a model off it using XGBoost. So we haven't done anything fancy other than maybe hyperparameter tuning, which is maybe a bit in advance of what we'd normally do, but why not do it while we're at it? So what's this going to do is now just run through all of the code. Hopefully shouldn't take too long. And then what we're looking for is our score to come up here. This to say complete, our score to come up here, and we'll get a good benchmark of where we're at. And then what we can do is come back to this and start doing some feature engineering. Let me just check everything is running. Oh, I've clicked that 3 times, that's not good. So let's just let this run. So this shouldn't take too long. It's not a huge notebook. If you remember, we've got to go through those 100 to be fair, we didn't actually even have to do that. We could have just copied and pasted this and set as a variable, but it's good to have the notebook kind of running as is for now. But you see that took about 1 minute 52. So yeah, this shouldn't take too long. I'd just say about 3 minutes. And hopefully no issues. So hopefully when this is done, it will come up with our score, and then we'll call it baseline for the evening. Oh, failed. Awesome. Let's do some debugging. Why did this fail? Unexpected car. Okay, sorry. So what we did here was we didn't ignore the index. Is Is it index equals false? Yeah, I'm pretty sure it's just index equals false. And then what we can always do is just copy here and just see if that actually, yeah, there we go. Okay, so if we don't do that, basically what happens, you can see you will get an unnamed column, which is not good. So, oops, wrong way around. So let's cement that again real quick. Another 3 minutes. We'll see where we get to, and then we'll call that the end of the stream. So yeah, let's see where we get to. So yeah, this should be 3 minutes again. That shouldn't get a failure this time. So yeah, sometimes you got to watch out for that. Again, the submission formats are important and key with this. Because if you don't get it right, Kaggle doesn't know what it's reading. You can submit them directly as a CSV. So if you go submit predictions, you can just drag and drop the CSV file in there, which is fine. But sometimes it's good to run the kind of whole notebook, just so if somebody wants to run your notebook, if you submit it, publicize it, it's good to know you've got it right. It's always a good debug and test, because it's very easy to accidentally go back and change a variable here and there and then it not run. I think, yeah, eventually we'll deal with some of these warnings, but let's see how we do. Let's see how we do as a baseline. Again, no feature engineering. We haven't done anything to the features. We literally just pop them in a model, tune the model, and then run it. So we've got our score, 357. So again, we're a little bit off what the Kaggle public leaderboard would have said. Oops. So let's see where we ended up. Oh, we're here. 538th out of 790. So not fantastic, but not terrible. But again, of course, we didn't do anything. We didn't do any feature engineering. We didn't do any data engineering. We didn't do anything. We just threw it in a model, and that was that. So what we can do next time is revisit this. We can actually play around with some of the variables, the features. Let's see if we can tweak them a little bit, make this a little bit better. As we kind of looked at this, and I've actually refreshed the whole page, so it's all gone, but if we remember the feature importance, the kind of fruit mass and seeds from memory were kind of the most important things. So like, we're kind of ignoring the rest of all of these, so there's got to be something in here that is useful. It can't just be fruit set and fruit mass. What that model is basically saying is, I'll just take those and we'll ignore everything else to make our predictions. So if we dropped all of that, we'd probably get a similar score. But that's not useful. That's not what we want to do. So if we want to climb up the leaderboard, we're really going to have to look at some engineering on these features. So what we'll do, we'll have a look at that next time. It's been a long hour and a half already, so we'll come back to the feature engineering side of things, and we'll make that model that we've created a whole lot better. So instead of this being best model, this is going to be baseline model, and then we'll actually create a best model. So thank you for kind of joining me. Hopefully next time we'll climb the ranks of the leaderboard. Hopefully this has been informative and useful to kind of watch along and understand how to approach Kaggle competition. Any questions, feel free to shout or ask them in the comments. Otherwise, see you next time. Ciao.